Hello. All right, this is going to be a video to discuss the concepts on the mechanical dimensioning rules. So I'm going to go into lecture material on your class Blackboard portal, and I'm going to open up the Technical Graphics Standards Manual PDF reference. And using the table of contents, we're going to jump right to mechanical dimensioning. And I want to go over these rules real quick and then demonstrate how we would apply those rules to one of the drawings that you will be drawing and dimensioning for the 6 drawings assignment to explain how you're going to tackle the dimensions. So let's look at the general rules. First of all, anything that you're dimensioning, the dimension should appear on the view that it shows up in its true shape. So I'm going to be using the frame guide as an example. This arc right here shows up in its true shape in this front view. So I place the dimension of that arc in this view. This notch is showing up only in this right view in its true shape. So I'm going to place the dimensions having to do with this notch, the location of it, the size of it, everything off of this view. These circles or holes show up in their true shape in this top view. So those dimensions would be applied to that top view that have to do with those features. Next is tolerance, and we do have a tolerance in this particular example. If we go to the original drawing for this, so let's go back to the lecture material and look at the original 6 drawings. The frame guide has a tolerance on this arc of 38.1 over 3797. This is called a limit tolerance, pardon me. And so this is an example of a very specific tolerance on a particular feature. The other kind of tolerance they're talking about here is a tolerance having to do with a general tolerance. I'm going to zoom in on our title block here so you can see what a general tolerance is. This drawing is in millimeters unless noted otherwise. And drawings that have whole numbers for dimensions, which is what this drawing has, that means that the tolerance applied to any dimension is 0.5 millimeters, plus or minus. So all the dimensions we apply to this drawing that we see appear here actually have some kind of tolerance applied to them because of that general tolerance. Let's go on to the next rule. Groups. Grouping dimensions together in multi-view drawings makes sense when the 2 featured items you're dimensioning have a relationship to each other. So if we look at what's going on with, let's say, the dimension for locating the center of this hole in the arch, and then locating the center of the holes here in the front of the frame guide, those 2 dimensions should be grouped together because it helps us to figure out where each one is based off of the last dimension. So in other words, I don't really know where to put these 2 holes if I don't know first where to put this one. The other dimension that could be grouped with those would be this 107. Because 107 as an overall dimension grouped with these 2 dimensions allows you to subtract 107 minus 51 minus 43 to get a resulting dimension here of 13. So you can group those dimensions together and it can help you figure out some things. And also we're going to talk about why that particular dimension, 107, should be a reference dimension. So grouping dimensions together when it makes sense to do so is a good thing. Also, notice that it says dimensions should be placed between views whenever possible. Next, we have spacing. And you know already about spacing because we've added dimensions to other drawings, but there's some specific rules about spacing that we want to apply to placing the dimension off of the object to begin with. Should be 0.375 to 0.5 inches, or convert that to millimeters. It would be about 0.5 millimeters to 6 millimeters off the part. And then all the subsequent dimensions that follow that should be 1/4 of an inch to no more than 3/8 of an inch separated from each other. And this converts to I'm sorry, these 2 numbers convert to 9 to 10 millimeters, and these numbers convert to 6 to 9 millimeters. Okay? Redundant dimensions are not allowed in mechanical. We don't want to repeat a dimension, and so I'll show you where we would avoid doing that. You also want to try to place the dimensions off of the part itself. So if we go back to our example, we have some dimensions that are showing up on the part itself right here. Let me see if we have any others. Now that's the only place. So even though it's doing that on this isometric view, I actually want to find a better place to put that dimension so it's not on the part itself. Some other examples of that would be right here, this R54. We're going to find a better spot to put that dimension. We're going to have a better spot to put that 16 millimeter dimension. So just because it shows up like that in the isometric view, do not assume that that's correct for placing the dimension. All right, next, crossing lines. It is okay to cross extension lines. You want to avoid crossing dimension lines. What's the difference between an extension line and a dimension line? If we go back to this view, this is an extension line, that is a dimension line. And we want to avoid crossing those dimension lines. So we'll get into that when I start demonstrating the drawing. Radius and diameter dimensions. When do I use radius? When do I use diameter? Most of the time, circles are going to be in diameter, and radii are going to be when you have partial circles. But the frame guide is an exception, isn't it? This is a partial circle, but we're providing a diameter. The reason for this is this frame guide, it would be another part exactly the same size and shape as this one, but mirrored, creating a full circle that some shaft is going to fit into. So in this case, we want to provide a diameter because of the function of the part. But most of the time, we're going to provide a radius, or in this case, this 13 is giving us a diameter, which means we don't want to indicate the radius as well. We can figure it out by taking 13 and dividing by 2 to get the radius. Last note here is we have symbols. We want to use symbols in place of abbreviations whenever possible. So what we have here is an example of how not to dimension. And every single one of these dimensions is violating one of the ANSI standard rules. And somebody took a great deal of time to explain every rule in violation here, but it's just also very messy. It doesn't look easy to read. We've got dimensions crossing, leaders rather crossing dimensions, and we just don't like this. And these are the reasons why these are violations of the rules. If you look at the very next page, however, this shows the frame, cutoff holder being dimensioned properly. And you can see that the dimensions are easily read. We understand what the dimensions are dimensioning and which features they're calling out. And that is the ultimate goal, to make this as easy to understand and read as possible. Whenever we can, we've placed dimensions between views, but when it didn't make sense to place dimensions between views, like this grouping of dimensions, we didn't. Why is this not between views? Well, you can imagine what would happen if we were to extend all of these lines up through the view. It wouldn't make any sense to do that, because then it would make it hard to read the actual object itself. So these dimensions are down here because the features are down here. So this is an example of where we'd want to place those dimensions outside of the view for a good reason. This is an example of a reference dimension. It shows a parenthesis around the dimension. And that means that this is not having a tolerance. It's not controlling whether or not the part is going to be successful or not. So this just gives somebody some general information about the overall height of the part. Why is this a reference dimension? It's because we have the dimensions to add up to that with the 4, 41, and 17. And if I were to also make that a dimension with a general tolerance, we would end up with a tolerance conflict between these numbers and this one. Okay, so that's the long and the short of it. I'm going to now dimension this frame guide by going back and forth from the example isometric drawing. And so I'm going to minimize this so we can see that off to the side. Make that a little bit larger. And we're going to just kind of go back and forth and see where to place it. So my suggestion when you do this is start with a single feature and work your way out. Add the overall dimensions absolutely last. So I'm going to do a dim linear dimension from here to here and place that dimension off of the part a distance of 9 millimeters. Now, the tolerance of that dimension is not showing up, so it gives us an opportunity to work with tolerance right away. We haven't done that yet. This is not something I want to apply to every dimension, so I'm going to select that one dimension, go into Properties, slide all the way down to the bottom where I can see tolerances, and I want to change my tolerance type from none to a limits tolerance, which will stack 38 over 38. I also want to set my tolerance precision to the number of decimal places that are being shown on the example drawing. So I set it to 2 decimal places. I also want to make sure I do not suppress 0, what do you call it, 0 decimal places. I want my tolerance position vertical to be middle. And the reason for that is we're going to put a symbol in front of this, of a diameter symbol, and we want it positioned in the center. Now, this is not saying the correct numbers yet. We're supposed to say 38.10 over 37.9. The 37.9 is the correct lower tolerance. So let's just expand these so you can see what's going on here. So correct lower tolerance is, we got a limit lower and a limit upper. The limit lower to remain 37.97 should be added to 0. The limit upper to get 38.10, if we do some math, 38.1 minus 39.97, we want to, 38.10 minus 37.97, we have a positive 13 to add to that upper limit. So I'm going to put in 0.13 and hit enter. And now we can see that we have a 38.1 but no 0. We want that 0 to be here. Oh, I'm sorry, I might have, yeah. So this, we want to suppress, we don't want to suppress either of these, I realize. You don't want to suppress this or this. There we go, now we get the right result. Now to add the diameter in front of this, I'm just going to double click on the dimension to edit it and put in %C, which is what we can put in for a diameter symbol. And then that adds the dimension that we need for that arch. Now we have the arch diameter, but we don't know its location yet, or its location yet. So we have to do that. And I also should have a center mark on this. So let's switch to the center layer and place a center mark. And we'll get rid of that. And the ends of those circles there. All right, so that gives us a center mark, and it shows that this center line is lining up with that feature. So the next thing that we want to add to this is how to locate the center of that. And you can see that these center lines are lining up with the feature on the top. So that means this dimension of 51 is not only locating that circle, it's also locating the center of this arch. So I can put that in that top view, and it takes care of both. So I'm going to go ahead and do that. Add a linear dimension from here to the center of that circle, and then track off of one of the edges 9 millimeters. And then use dim continue to track to the 2 circles here. This makes sense to put this in this view to locate those 2 features. And because I have these center lines connected, it's also locating the center of that arc there. Go back to our references. We've taken care of that dimension, this one, and this one. Also, do not deviate from any dimensions. Use the ones that have been provided. So let's pick another feature. Since we're up in this top view, let's go ahead and pick the rest of the features that have to do with these circular features and arches. So 2x stands for 2 times a diameter of 10 for these 2 circles. And then we also have a distance of 22 between them. And we have the radius of the arches is 2 times the radius of 13. So let's add the dimension between the 2 circles first. It's going to be a lot easier to place that linear dimension, which is a lot more restrictive of where it needs to go, and then place the diameter dimensions around them. So we use DDI to place the diameter dimension first, maybe. And then I can use DRA to place the radial dimension. And I decided I want to put it on the other. Let's put that there and stack it right on top. That looks good. You can now put in 2x space and 2x space for those 2 dimensions. So now we have taken care of 1, 2, 3 dimensions. These are all the dimensions we need to locate those 2 holes and to create those 2 radiuses. So we'll move on to the next feature. Let's take this notch now. The only place to see the notch in its true shape is in this view. So we want to take the dimensions for that notch, 13, radius of R, which is half of 13. I'll show you how to suppress everything else about that dimension. And we need to locate how far up it is and how far over it is to find its center. So let's put in those dimensions between views. Let's get that dimension in there and go up 9. And then we also need to put in a dimension from center to center. And that's a problem because I have to cross dimensions if I do that. And so I'm going to place this dimension 9 millimeters up and then move this one an additional 6 millimeters up. And then I can show you that we can put a break between this extension line. We don't want that extension line crossing through that dimension. So we can use a command called dim break, which is not one I think we've had a chance to use yet. Select the dimension that you want to break, and then select the extension line you want to break it with. Let's try that again. I think I needed to pick the extension line first, and then the dimension. And it doesn't seem to want to work, so we're going to try something out. We'll use dim break. And we're going to try selecting the extension line, and then we're going to use manual to specify the breakpoints. So I'm just going to track off from that node there and click, and then click again, and it creates the break manually. Another way for us to have done that is to take the dimension of 13 and just move it to one side or the other, and then our extension line doesn't have to be broken. So either one of those solutions works, in my opinion. So let's add a radial dimension off of this arch, and we'll put it off to the side here. But I don't want it to say R7. I want that to just say R. So I'm going to highlight it, delete it, and type in the letter R, capital. We also have to locate the dimension height. So I'm going to put in the dim linear command and go from here to here and place that dimension on in between views. There we go. Now, in the example drawing, it puts that dimension over here. So you'd think, well, let's put the dimension here on the side. No, I want to place it on this side, because then my 41 millimeter dimension is also going to be grouped with that, and it's going to be between views. So this is an example where we force that dimension to go between views because we can. So I'm going to use dim baseline to place the 41 dimension. And then I've got all of my dimensions grouped together and having to do with that part. We do have these corner fillets, so we'll use dim radius to add a fillet dimension. And in this case, we have to push that around so that the arrowhead isn't being crossed over by both of these extension lines. And when an arrowhead does cross an extension line, you should dim break it. Or you can just take that origin and move that origin just out a little bit so that it doesn't cross over the arrow. And then we'll bring that dimension in so it's aligned with the 41. So now if we go back to our dimensions, we have taken care of these two dimensions, and the 2xr5, we'll add that, and we've taken care of the 13. So now we have to add the dimension of 5 and 11. And then the radius of 30. So DRA for radius of 30. And we can put it here. That's fine because that's not actually on the part, it's on the hole. In the isometric view, it puts it, it looks like it's on the part itself. So this works, or you can select the dimension, go into properties, and you can play around with the fit tab, where you can move the text without leader and take that text and move it around until you like the position of it. I don't love it going over the other dimension, but I don't mind it doing something like this, and that would be all right, where we have a radius of 30. Okay, so then it's not on the part itself, it's kind of stuck out here. Now let's add linear dimension from here to here. and go up to the same height as this, so I can track off of that point. That's 11. Should also be 11. And I'm going to track to that 22, so that goes out the same distance there. See how you're making sure consistency is happening. Now that last dimension, we have two more dimensions. We have a dimension that we need to add for the width. And this is the best place to put that width as a dim baseline dimension, because it's grouping those dimensions together where I can see that 24 is half of 48, and I can tell that that feature is centered. Okay. The only other dimension I think we have now is our overall length dimension, and this is now should become a reference dimension, because we're able to take the 51, the 43, and the 13 and add it up to 107. So I'm going to keep that dimension here outside of the view by putting in a dim linear dimension from here to here and going down to here, and then moving that dimension down again another 6 millimeters. And then I want to put a parenthesis around it. So I'm going to put a parenthesis around the dimension itself, so that I make sure it's showing as a reference dimension. And then because it's looking a little too crowded there, I'm just going to push that over. Last dimension we need to add is the diameter dimension here, and I will put that right on top of these two dimensions and then pull those out another 6 millimeters, so that this spacing is the correct spacing, and then that's the correct spacing after that dimension. And then we go back and double check, did we get all of our dimensions? So you're just looking back and forth. We have the 210, 213s, the 22, the 11 showing up here, the 11. We have the 107 as a reference dimension. We have our tolerance. We have our radius. We have our 24, 48. Let's make that a little bit smaller. 13, 41, and 25. We have it all. So the last piece is adding those fillets. We can add that as a note, just like that. So we can create text with a note here. All rounds and fillets. Let's make those all caps. R2. And that is a perfectly acceptable note for us to add to this drawing. And then we have properly dimensioned that. So very important to pay attention to spacing, very important to pay attention to where you place the dimensions so that they show up on the features, where those features show up on their true shapes. And it's really important to pay attention to organization and making sure things are readable.